Hello everybody, welcome to our lesson today. We are on lesson 4, week number 3, Natural Science Grade 8. My name is Arifa Hafaji and I hope you have an enjoyable time learning all the information which I have prepared for you today. So we're going to recap with what we did yesterday first, and we're going to start with before I start with that, our lesson for today is on chemical reactions. I will inform you what a chemical reaction is, what happens to the atoms and the bonds in a chemical reaction. We're going to identify some reactions and products, and also we're going to give you some examples of indigenous practices when you're identifying chemical reactions. So a recap of yesterday's lesson quickly is the particles of matter are constantly moving. In solids, these movements are limited to vibrations. So in a solid, the movement is they vibrate against each other. But in a liquid and a gas, they are basically free to move. So most materials will depend on whether it is heated or if it contracts or it's contracted. That means when it is cooled. This is because heating makes the particles move further apart and cooling makes the particles move closer together. So the important thing you need to know here is heating makes the particles move further apart and cooling makes the particles move closer together. So when we want to know how much of gas we have, we measure it using a pressure. And the example I used yesterday was the pressure gauge. Now, the pressure of a gas is caused by particles of the gas colliding within the container inside. So the gases basically collide against the walls of the container. And then the more gas particles inside the container basically means that there's more collisions. And because there's more collisions, there's more pressure. Also, if you decrease the volume of the container, then there's also more pressure because the particles get closer together and there's less space. That means increased in pressure. So I'm going to go through a quick recap very, very quickly on the particles model of everything that we learned so far since I started with you. So basically, and this is how one of the ways you can learn as well through a mind map. It's a very interesting way because then you don't have to go through pages and pages of learning. You just learn through this mind map, which makes your life very easy. So the particle model of matter basically explains all matter, and all matter is made out of particles. And then we say particles are in 3 states, and the 3 states is the solid, the liquid, and the gas, but we'll come back to that. And we'll say now particles basically have spaces in between them, which are basically empty. So the spaces in between them are empty, there's no air in between it. And the particles refer to atoms and to molecules. Particles are too small to see, so you cannot see it with the naked eye. You need a microscope to look at the atoms and the molecules. And the particles depends on the material that you are using it. Now the 3 states, they differ in density. That is the solid, the liquid, and the gas. It differs in density. And the density depends on the material that you are using and also the amount of mass per volume. So you can take a picture of this or you can download it from YouTube later on and you can use it for studying purposes when you're going to study and you're going to go back to school. So coming back to the 3 states. So we can change the state either by heating or by cooling. So who knows the answer? You can type it on in the chat. So if you heat it, what does the heating cause that allows the space to increase? So heating causes Okay, so I think there's a problem with regards to what the screen is showing. So I'm just going to close this, and then okay, so can I just stop presenting, close the other thing that I had, and then start again? I'm so sorry about this. Okay, so I hope it's okay now. I'm just going to put it on a view that is big for you so you can all see properly. Okay, is this better? Right, so now let's see your answer. We're going to say that heating, thank you, heating causes something. What happens when you heat the particles as the spaces increase? Who knows that answer? So we say heat, if you heat the atoms and the molecules, what happens to the spaces to make it increase? Does anyone know? Okay, so I will tell you. So basically, vibrations. The heating causes vibrations as the particles increase. Okay? And then we say the cooling causes, let's see, what does the cooling cause? Cooling causes a loss of energy as the spaces decrease. Now, when the spaces decrease, we're going to look at what gap we're going to fill in here. We say that the, sorry, no, not that one. We'll come back to that one. We'll just say that when you lose energy, the spaces decrease. So now we have your solid, we have your liquid, and you have your gases. So basically here we say that the solid evaporates to form a liquid. And then the liquid exerts pressure. And this pressure collides with the particles. Now gases have no arrangement and they move very fast. There's very weak forces and they have very big spaces. Now liquids, when they solidify, that means that when it becomes an ice, when it freezes, they are closely packed, they do not move around, but they vibrate, they have strong forces, and there's small spaces between them. So in a liquid is loosely arranged, and they slide past each other, and they have weaker forces and smaller particles. And in the gas, they have no arrangements, and they move very fast. And this means that they can diffuse. And when they diffuse, they move from a high concentrated area to a low concentrated area. Okay, so we're going to start with chemical reactions. We're going to observe, we observe chemical reactions visually, or recorded by sight. That means that we can see it. We see the chemical reaction happen. And we use other senses that also helps us to check whether a chemical reaction would occur or not occur. Now, sometimes chemical reactions can be smelled. For instance, when a new chemical that is strong, it is formed. And then we say other chemical changes can be felt. That means that when the reaction, it produces heat. That's how you can feel the chemical reaction, because it would produce heat. And some chemical reactions can be heard, like, for example, an explosion that takes place. Now, before I proceed, I just wanted to check that I didn't miss a slide and we didn't have any technical issues. Okay, so now we're going to continue. Substances can react from each other to form products with different chemical properties. Now, because chemical properties are different, so substances react with them, and when these substances react with them, they form products. Okay, so I'm going to say that again. We say some substances, they react with different chemical properties. They have different chemical properties. So they react together, and then when they react together, they form products. Okay, now in a chemical reaction, the substances that react with one another are called reactants. So when two substances react together, they are called reactants. Like, for example, when hydrogen and oxygen react with each other, they are called the reactants. So it's separate first. You have the hydrogen atoms and you have the oxygen atoms, and it's two separate. These are, and I'll show it to you in my next slide, but these are called the reactants. Now, the substances that are produced, that means when you mix the hydrogen and the oxygen together, it produces water. So the substance that is produced from the chemical reaction, they are called the products. So important for you to know is, in a chemical reaction, you get reactants, and then when you add the two reactants together, you get a product. In reactions, the rearrangement of atoms take place to form different products. So the atoms, they rearrange themselves. Remember in the very first lessons that I did, I showed you the atomic structure. So they rearrange themselves and they bond together and they form products. And they bond together by chemical reactions. So now we say the difference between a physical and a chemical changes. So what is the difference between physical and chemical changes? Before I do this, okay, never mind. So we need to decide whether there's a change in physical or a chemical change, and then you can write down your answer, or you can send it on the chat to tell me whether, if you had to change cutting up potatoes into cubes, do you think this is a physical change or is it a chemical change? If you had to cut up potatoes into cubes, does anyone know? You can type it into your chat. Okay, so while I'm waiting, I'll go through all, and you can tell me if it's physical or if it's chemical. So boiling water in a pot or on the stove, is this a physical change or a chemical change? Then frying eggs in a pan, is that chemical or physically changing? Is the egg physically or chemically changing? Whipping egg whites. So the process of whipping, is it physical or chemical? Then dissolving sugar in water. So if you had to dissolve something, is it a physical change or a chemical? Now burning gas in a gas cooker. Now if the gas is burning, is that a chemical change or is it a physical change? And then your ice cream melts in the sun. So if your ice cream had to melt in the sun, Is this physically changing or chemically changing? Does milk turning sour, is it chemical or physical change, or an iron gate outside that rust? Now, is the iron gate rusting outside, is that physically or chemically? So let's see the answers. So cutting the potatoes is a physical change, and boiling water on the stove is a physical change. Frying the egg in the pan is a chemical change. Now the reason for that is that the egg proteins undergo a chemical change and cross-link to form a network. Now whipping egg whites. This is physical because the air is forced into the liquid, but no new substances is made. Dissolving sugar in water. This is physical because the sugar gains are dispersed within the water, but the individual sugar molecules are unchanged. Okay, so I'm going to repeat this one because it may be confusing for you. So dissolving sugar in water, we say it's physical because the sugar gains are dispersed in the water. Okay, but the individual sugar molecules, they remain unchanged. So the sugar is still in the water. It just changed from a solid to a liquid, so it's a physical change. So burning gas in a gas cooker is a chemical change because water vapor and carbon dioxide form. So when you burning gas in a gas cooker, you have carbon dioxide and water forming. So your ice cream melting in the sun, the melting process is actually a physical change. And the milk turning sour, that's a chemical change because when the milk turns sour, lactic acid is produced. So another substance is formed. Now your iron gates that rest outside is a chemical change because iron oxide forms, and for this iron oxide forming, you learn more about that in grade 9. You don't need to know so much about it in grade 8. You just need to know that an iron gate rust outside is a chemical change because iron oxides form. Okay, so I'll just leave this on for about 20 seconds for you to digest the information, and then I'll move on to the next slide. Or if you want to ask me a question, you're welcome to do so on the chat. Okay, so now we're going to use chemical reactions to see inside an egg. So we're basically going to find out how can we use a chemical reaction to see inside an egg. So we will now put our checklist into practice to see the safe reaction, and you can try to take it home. So have you ever wondered what a raw egg would look like without its shell? So if you look at the man that's holding the egg, basically you can see that he's holding this egg and it does not have a shell. So we're going to use a chemical reaction to strip away the shell of an egg without breaking the egg. So what we're going to do is we're going to use a semi-chemical reaction. And I want you to try this investigation at home. So we're not going to complete the investigation. First, you're going to try it, you're going to prepare it, then you're going to leave it for 4 or 5 days, and then when we come back on Tuesday, I'm going to ask you questions. So your steps, what you're going to do. You need to carefully place an egg in a glass bowl, and then be careful not to crack the egg off the shell. So don't use a very big bowl because you're going to cover the egg in vinegar. So use a small bowl so you don't have to use so much of vinegar and you don't have to waste the vinegar. So you put the egg in and you cover the egg in vinegar. Now you must know that when you're covering the egg in vinegar, the whole egg must be covered right to the top, so you can see that the egg is fully in the vinegar. and then you can wait for a few minutes. Now, can you see anything happening to the surface of the shell? So what you're going to do is, after a few minutes, after you put the vinegar into the egg, then I want you to record what you see happening to, the surface of the eggshell. Then you can leave the egg in the vinegar for 4 or 5 days. And we're going to complete the rest of this activity on Tuesday. So I want you to leave the egg in the vinegar for 4 or 5 days. So today is Thursday. So you have Friday, Saturday, Sunday, Monday, and then on Tuesday, we'll complete the questions and answers that I have for you for this experiment. So, and then this is how you can observe how a reaction is taking place also. It may be necessary to top up the vinegar if the reaction starts to slow down. So you see, if you can see that no reaction is taking place, then what you can do is you can add more vinegar, or if the reaction is slowing down and you can see that it's not changing in any way, or no reaction is occurring, then you can add more vinegar. So keep it to a top level. And then remember to return to the activity on Monday. And when the eggshell has dissolved completely, I want you to record your observation. So by Monday, your egg should basically look like this, how this man is holding the egg. Okay, and then you can see he's pressing it, which means that even though it doesn't have an eggshell, he's pressing it, so it's like a little bit of rubber. Like when you press rubber, it's a bit soft. So we're going to talk about reactants and products. Now, before I go there, I just want to check my slide, because I did prepare another slide that explains certain things to you. But because when we had that problem, I see that it's not here anymore. Okay. So it's not a problem. What I will do is I will take that slide that I prepared for you, and I'll put it into tomorrow's lesson. Okay, so reactants and products. So how is it possible to change one compound into another compound? So in the meantime, what happens to the particles when compounds react? So in this section, we're going to explore this answer. But what I want to do is, the page that was missing that I don't have actually gives you the definition of a chemical reaction. So I want to tell you what a chemical reaction is. So the definition of a chemical reaction is the process that involves the rearrangement of molecules. So the two molecules, they rearrange themselves and they form a different substances. And then I had a diagram to show you how it rearranges itself to form the substances, which we do in tomorrow's lesson. I will add it in for you. So now, during a chemical reaction, the reactors are used to make products, which I explained earlier on. So we have the reactants, and these reactants are used to make products. And the atoms in the reactants have been rearranged to form new compounds. So these new compounds are basically the products. So when the two atoms, two different reactants react together, a new compound is formed. And another word for the compound is the product. So a chemical reaction is basically a rearrangement of atoms. So important for you to know is a chemical reaction is a rearrangement of atoms. So again, a chemical reaction, I want you to visualize it in your head. If you can picture all those atoms fusing together, so if it's a rearrangement of atoms, and then some of it attracts each other with the electrons and the protons, and the new products are formed. So in order to change a compound into a different compound, we need to change the way in which the atoms in the compound are arranged. So we say in order to change a compound into a different compound, we have to change. So the main word here is to change. So you're bringing about change. So when you change the way the atoms are arranged, then your new compound is formed. So it's no longer in its same original state. It's moving to a new form, a new compound. So this is exactly what a chemical reaction is. So you can take this down as well, or you can say it with me. It is a rearrangement of atoms to turn one or more compounds into a new compound. So a chemical reaction is, in the test, they can give you a 2-mark question and they can say, what is a chemical reaction? So you're going to say, it is the rearrangement of atoms to turn one or more compounds into a new compound. So rearrangements of atoms would be basically 1 mark that you would get, and to turn one or more compounds into a new compound, which should be your 2nd mark that you would get for your answer. Okay, so anytime atoms separate from each other and recombine into different combination of atoms, we say a chemical reaction has occurred. So this is basically the same thing I've explained in this top sentence, but in a different way. So we say anytime atoms separate from each other, so when atoms separate from each other, they recombine into different combinations of atoms. So that's basically a rearrangement of atoms. So it's a different combination of atoms, and then a chemical reaction has occurred. So these two are very important for you to learn and memorize. So this is like part of the picture that I had in the first slide that's missing. So I'm going to show you what the reactants and what the products are in the form of these particle arrangements. So we are going to use these colored circles to represent atoms. So this circle, grayish circle here is one atom, and then these red circles here is another atom of a compound. So these two are different compounds, and it takes place in a chemical reaction. So if we have these beads, you can use beads or you can use Play-Doh that you may have, or your brothers or sisters may have, and then you can make reactions yourself on your desk to basically learn the concept of reactants and products and the process of the chemical reaction. So we're going to say, if we have carbon and oxygen on the left arrow reacting to make carbon dioxide on the right arrow. So basically we have carbon here, the gray circle, and we have oxygen. There's 2 atoms of oxygen, which is the red circle. And if we combine these two, then on the right hand side of the arrow, this arrow here, you see that the oxygen atoms are attracted to the carbon atom, and they make carbon dioxide, which is basically, if you had to write it using figures, so it's going to be CO2, the small 2 at the bottom. So the 2 means that there's 2 atoms attached to the 1 carbon compound, 1 carbon atom. Okay, so to the left of the arrow, we have the before situation. So this is before. Before we had carbon and we had oxygen. And this side represents the substance that's before the reaction takes place. And this is called the reactants. So this is basically called the reactants. So on this side of your diagram, it is the reactants, where we're taking two different compounds and we're putting it together, and we call these the reactants. And then to the right of the arrow, which is on the right side of the screen, is the after situation. So the after situation is when we added these two atoms together, and then we say that the reaction has occurred, and when the chemical reaction has occurred, this CO2, carbon dioxide, is now the product of the reaction. Okay, so it is the product of the reaction. So if you had to take, like say in a frying pan, you had to take a little bit of butter and put it in, and if you had to put your egg on top, and if you had to apply heat, and then you fry your egg, then you will have a fried egg. So the product of the fried egg is the butter, the egg, and you applied heat to it, and it became a fried egg. Okay, so that's just explaining it in a little bit different way for you. So reactants are before the reaction. So we say reactants are before the reaction. And we have products. Products are after the reaction. So do you see that how the atoms are rearranged? So can you see on this picture here how the atoms are rearranged? This means that a chemical reaction has taken place. So when the atoms are rearranged, it means that the chemical reactions have taken place. So I want you to draw this diagram down now. And when you're going to draw it, I want you to label it. Which ones are the reactants? You can label it here. You can write the answer. And which is the products? You can write your answer here. So it basically puts whatever I discussed with you into perspective. So you'll know what the reactants are and what the products are. Okay, you can also write an equal to sign here, and you can say how you're going to represent it in correct terminology instead of a diagram. Okay, so I'll leave this on for you to draw it quickly for about 20 seconds. So before I move on, don't forget to label it reactants and products. And later on as well, you could take different color beads or marbles or Play-Doh. You know, if you don't have Play-Doh, you can actually make Play-Doh. You can take some flour and water and make a dough and add some coloring in it, which would be quite fun for you. And you can make your own dough. And don't forget to throw it away when you're finished, or you could keep it in the fridge if you want to for a little while so you can play with it later. And you can draw different, you can use your periodical table and you can draw different reactants. You can, with your dough that you're going to make, you can make reactant compounds, and then you can make product compounds. And you'll actually learn it in a nice way. So if you look at the diagram below, it represents another chemical reaction. So here we have oxygen in the red molecules. So these are oxygen molecules, and we are reacting them with hydrogen, which is the white molecules that we have here. So this here is you can say it loudly, even though I won't hear you. So you can say it with me. So this, on this side of the arrow, is the reactant, and then these two form a product. That's correct. So the oxygen atom formed with the hydrogen atoms, and it formed basically water. and this oxygen atom formed with these two hydrogen atoms, and you formed a water molecule. And then when you write the water molecule, you write it like, excuse my writing, it's H2O. Okay, so what are the reactants in this reaction? So it's your turn now. I did explain it to you. You could say it loudly, or you could just reiterate what I said. What are the reactants in this reaction? You can actually write it down. I'll give you a clue. I'm underlining it for you. Okay, so you can draw the molecules, and after you draw the molecules underneath it, you can actually write out what the reactants are. Right. And then you're going to ask, what are the products in this reaction? So what is formed? So you can write it down, what is formed. So what is the product means that what was produced, and I'll underline it for you here so you know what it is. Okay, so under each molecule, you're going to write what the reactant is, and under the product, you're going to draw the product, and then you're going to write what the name of the product that was formed. So why do you think hydrogen and oxygen are represented in two atoms joined together? Okay, so it's something to think about. Now, why do you think hydrogen and oxygen atoms are joined together? So, and do you remember when we spoke about chemical bonds? So, we say chemical bonds between the atoms in a molecule. So we did this in a previous lesson. So a chemical bond is a force that holds the atoms together. So basically, before I read this, I'll explain. What happens is the hydrogen atoms were attracted to the oxygen atoms through an attractive force, and they bonded together to form the water molecule. Okay, so together therefore during a chemical reaction, the bonds between the atoms have a break so that the atoms can rearrange to form the products. So we say the bonds between the atoms have to break so that the atoms can rearrange to form the products. So new bonds form between the atoms in the products. So when we have these bonds that are formed, these chemical bonds, we have new bonds that are formed. Okay, so I'll go through it just one more time. We say a chemical bond is a force that holds the atoms together. Therefore, during a chemical reaction, the bonds between the atoms have to break. So the bonds between the atoms, they break. So the atoms now rearrange. So the atoms can rearrange to form the products. Okay, so new bonds form between the atoms. So now what I want you to do is I want you to say what I said in your own words. Because when you put things in your own words, it's part of a learning process. You begin to understand what I am saying, and you internalize the information, and you tend to learn better. So there's two learning strategies. One, you can do it visually. One you could use with your and the others you can use using your hands, that's concretely as well. And then you can also learn through reading as well. That's actually 3 ways. So you put it in your own words when we say a chemical bond is a force that holds atoms together. And during a reaction, the bonds break, and then the atoms rearrange themselves to form products. And then we have new bonds are formed to make a product. Okay, so during chemical reactions, materials change into new materials with new chemical and physical properties. All right. And the materials we start with are called reactants, and the new materials that are formed are called products. And during the chemical reactions, atoms are rearranged. So this requires that the chemical bonds in the reactants are broken and that the new bonds are formed, resulting in a product formation. Okay, so I'm just saying that again slowly. Atoms, during a chemical reaction, atoms are rearranged. So this requires that the chemical bonds in the reactants are broken. So basically your reactants are broken and new bonds are formed, which causes a product formation. There's really very nice information for you on YouTube. If you look at this YouTube video here, it explains physical and chemical changes that we did through the lesson. So this is part of visual learning. And then the naked egg experiment as well. So if you watch this YouTube video, it would give you an idea of how to conduct an experiment. So sometimes when we conduct experiments, we're not really sure. What we do is we use the form of modeling. Modeling means that we see how other people do it and we watch how they do it and we actually learn from them, because we all learn from each other. You know, I can also learn from you even though you are so young. So we, throughout our life, we always learn from each other. So all the information from this tutorial was derived from the Siyavula's book on the internet, which is a free resource, and also the Department of Education uses this resource as their workbooks on the internet. If there are any questions, please can you type it on the chat and I will gladly and happily answer it for you. So our next lesson is formation in chemical substances. But what I would do is I would start with that slide that I had prepared for you to just explain to you a recap of the lesson, because that first slide I had basically recaps my lesson. I mean, basically tells you my lesson really well. Okay, so when you draw the molecules, you have to be in a specific way, or you can draw it anyway. You're welcome to draw it in any way, as long as that it is arranged. Let me show you. Okay, so let's just say you have your hydrogen. Let's make a water molecule. So you have your hydrogen atom here, and you have your oxygen atom here. Okay, so we're adding the hydrogen and the oxygen. So here you can draw it in a way, but the oxygen atoms, because it's two molecules, because you have O2, so they next to each other because they attract each other. Okay, just remember that. So then when your chemical reaction is, you're going to use the arrow to say. So when you're forming your bond, so you actually should form your bond like this. So you put, this is actually supposed to be straight lines. Forgive me for my crooked line. So you show that the oxygen atom has bonded with these two oxygen atoms have bonded with the hydrogen atom. I know in the previous slides, I think we showed it to you like this, where you had it. So the slide, excuse, that's supposed to be a circle, and you can draw it like that to show that it is bonded. Just forgive my drawing. It looks like, okay, don't worry about what it looks like. So you can draw it in these two ways to represent it. But the more correct way is to show this bonding, because it's called, you learn later on as you go on, it's called covalent bonds, which I'll teach you, which is an attractive force that attracts the molecules to each other. So the ones that I showed you basically were like this, but the proper way is to do it with the covalent bonds. Is there any other question? Okay, so if there are no other questions, oh wait, one more. So we say, so what you're going to do is you're going to take a small bowl at home and you're going to put your egg in a small bowl. Um, but the bowl must be big enough for the egg to fit inside. And then you're going to take vinegar if you have, and you're going to cover the egg in vinegar so that the whole egg is covered in vinegar. So yes, that is your homework because I'm giving you an investigation to do the egg. And then what you can do is and what I'm going to do is I'm going to load up pages for you. I'm going to ask them to load up pages for you on the internet that would give you homework to do, so you can consolidate everything that I taught you in particles of matter previously. So I'll get those pages loaded up for you. So look at this YouTube video, the naked egg, and it will give you an idea of how to conduct it. But then don't look at the video and then say, oh no, I know how it's done. Try to do it yourself because it will help develop that scientific skills in you. Because what I'm going to do in my next lesson, which is not tomorrow, on Tuesday's lesson, because we're going to wait 4 or 5 days, I'm going to put up questions, and then those questions that you'll need to answer, and you'll only be able to know how to answer it if you did the experiment. And it will be fun for you, and it's something for you to do to help you become scientifically inclined. And it's not, and the way we learn is basically through experimentation. And the greatest scientists always experimented, and while they experimented, they formed new ideas in their minds to develop basically most of the things that are that have made our lives easier, like especially electricity and the use of telephones. And you can see how the development of telephones have led to technology that we're using now, where I can teach you online. So learn, and one day hopefully you'll become a great scientist and you can develop something really great and say, wow, I'm proud of myself, because it's always nice to be proud of yourself and happy with yourself. Okay, so I'll see you again tomorrow. We'll do fermentation and chemical reactions. Have a very lovely day, and I hope you have benefited from my lesson today. Goodbye. See you tomorrow.